This video is going to show you how to solve the Chapter 6 Bayes theorem problems with a tree. We will also do Siegel problem 18 in Chapter 6 in illustrating this. So let's recall where we're at. Chapter 6 really culminates in showing you how to solve Bayes theorem problems, where you've got two variables and you have to find a bunch of different conditional and marginal probabilities about those two variables. Now, I said that there were a couple different ways of solving Bayes theorem problems, two of which are very easy. So the way that I've kind of emphasized in class is what I call the crosstab approach. Siegel calls it, the conditional probability table approach, whatever he calls it. The approach that Siegel recommends is called the tree approach. And to be honest with you, I think the tree approach is also very good. I use it quite often myself. So, you know, it's an alternative method. You don't have to know the tree approach, but what I find is it's really good to know both approaches. So I guess master the crosstab approach first, and then it's really worthwhile learning the tree approach as well. So to do the tree approach, I think I'll illustrate it with a problem. So let's go over to the SketchBook Express. The problem that I've chosen for us is 6.18. Let me just read it to you here. 6.18 is, there are two locations in the town, north and south, under consideration for a new restaurant. But only one location will actually become available. Now, I'm going to define some events. So let big N be the event that the north is available. Let's read on now. If it is built in the north, that sounds like a conditional probability to me. The restaurant stands a 90% chance of successfully surviving the first year. So this, I'm going to use the letter S to be the event that the restaurant successfully survives the first year. So let's translate this statement into symbols. If it is built in the north, so what we're told is that it is built in the north. The restaurant stands a 90% chance of successfully surviving. So the chance of survival or success, whatever you want S to mean, is going to be 0.9. However, if it is built in the south, I guess my notation is going to be a little bit confusing here. If it is built in the south means that it is not built in the north. So N with a bar over it means south. Right? The chances of survival are only 65%. So the chance of survival, given that it's not in the north, is only 0.65. It is estimated the chance that the northern location will be available 40%. So that sounds like an unconditional probability. The chance that we get the north, obviously we'd like to have the north since the probability of success is higher. It looks like a better location. It was only 0.4. Now, the way I see these Chapter 6 problems is what's given. Now, there are really three possibilities of what could be given to you. So in this case, we're given a marginal probability and two conditionals. When you're given a marginal and two conditionals, the problem is definitely most easily done with a tree. The crosstab approach requires a little bit more work, I think. Many of the problems will give you two marginals, so they'll give you the probability of n, they'll give you the probability of success, and then they'll give you some joint probability. In that situation, the crosstab is easier. A lot of the problems will do something like two marginals and a conditional. In that case, I would say the two methods are about the same. Okay, so let's draw a tree. So what the tree approach involves is depicting the sample space with a tree. Okay, so we're going to split up the sample space as follows. This is all the portion of the sample space where we get the north. Down here is where we don't get the north. So here we're in the south. Now, I'm going to write the size or the probability of being in each region of the sample space at the end of this tree. So the tree is going to go horizontally here. So the probability of being up here is 0.4. The probability of being in the south is going to be 1 minus 0.4, which is 0.6. Now, one thing about trees is that all of the leaves, you can think of this as a leaf and this is a leaf, must add up to 1. That's always going to be true with these trees. So far so good. Now the next thing we're going to do is continue to partition the sample space. And here's what we're going to do. This is success or survive. This is where it doesn't survive. This is where it survives. This is where it doesn't survive. Now I'm going to write along the this edge the conditional probability. So when we're up in this branch of the tree, we know it's the north, right? So given what is the chance of success given the north? It's going to be 0.9. What is the chance of not success given that you're up north? Well, 1 minus 0.9 equals 0.1. Let's do the same thing down here. If we're in the south, what is the probability of success? Well, it's 0.65. What's the probability that we don't have success? 1 minus 0.65, which is 0.35. All right, so within this mini tree, things add up to 1. Within this mini tree, things add up to 1. Now the end leaf is going to give the joint probability. One rule with trees is you just multiply across. So this is going to be 0.4 times 0.6 equals 0.36. This will be 0.4 times 0.1, so we just always multiply across 0.04. This will be 0.6 times 0.65 equals 0.39. And this is going to be 0.6 times 0.35 equals 0.21. Now if you want to check your work, all of these leaves should add up to 1, and sure enough they do. Now let's just think a little bit about what I've done here. Remember the probability of S given N, let's just start with that, is really the probability of S and N divided by the probability of N. Alright, now we know this is 0.9, we know this piece is 0.4, therefore the probability of S and N is 0.36. So that's exactly what we've done here. So that's just a joint probability. Think of this as the probability of S and N. This is the probability of N and not S. and so forth. All right, we've now completed our tree. Let's answer the question. So part A, draw the probability tree. Well, we did that. So here's part A. Part B, find the probability that the restaurant will survive the first year. So what is the probability of survival or success? I'm going to erase this so that I have a little bit more space. Well, there's two ways that we can survive. This way or this way. And we just add those up. So you can think of, what is the probability of survival? Well, either I'm in the north and I survive, or I'm in the south and I survive. So this is going to be 0.36 plus 0.39 equals 75%. So just add those two up and you get the answer. Part C, find the probability that the restaurant is built in the south and is successful. So what is the probability that it is built in the south, that's n bar, and is successful? Well, this is really easy. We just go pluck it off the tree, 0.39. Part D, find the probability that the restaurant is in the south given that it is successful. All right, well, this is just what is the probability that it's in the south and it's successful divided by, well, how big is success? So it's just, you know, conditioning on the fact that it's successful. So 0.39 divided by 0.75. They've already set us up for this, as you can see. So 52% is the answer. Part E, find the probability of failure. So what is the chance of not success given, all right, given that it is in the north? Well, this one is right on the tree, so 0.1 is the answer. And so we're done. It's instructive to now work this as a crosstab problem. I'm not going to go through the whole thing, but let me sketch out the crosstab approach for you. And then I'm going to let you work on some of the details. So let's draw a crosstab. And we'll put the north here. This is the south. Let's put success over here and let's make this failure. Now let's go drop in the given, which is what we would usually do. So this is going to be 0.4. Remember, everything has to add up to 1. And note we do exactly the same computation here as we did over here to get the chance that we're in the south. Now, what we would do next is that computation that I had to do up here. I took 0.4 times 0.9. Oops, that's a mistake. That should be 0.9 right there. To get this number, 0.36. And then I'd have to do something similar for down here. And I would find 0.39. Then we would do some subtraction. We would find this to be 0.21 if you take 0.6 minus 0.39. This is going to be 0.04. Then I'd add these up to get the two marginal probabilities. And so what you're going to see here is that the crosstab partitions the sample space, and so does the tree. And you know, we get to the same partitions at the end of the day. We just get to them in a slightly different way. So these 4 leaves are exactly what we have in these cells. It's just that we got to them a slightly different way. So either way gets you the right answer. It's just that when you're given 2 conditionals, I find it a little bit easier to work with the tree. So what I'd encourage you to do is go through a fair number of the problems in Chapter 6 and work them both ways. Then you really master both techniques.